Host discovery scanning is the process of identifying systems on a network that are alive and actively responding. Host discovery is the first and most fundamental task in network scanning. Before an attacker can perform a detailed scan for open ports and services, they must first determine which hosts are online. This step is crucial because it allows an attacker to focus their efforts on live targets instead of wasting time probing every possible IP address in a large network range. This section covers various techniques for checking for live systems, including several types of ping scans. Host discovery techniques to discover active hosts on a network. An ethical hacker can employ several methods. The most common techniques include ARP ping scan, UDP ping scan, ICMP ping scans, echo, timestamp, address mask, TCP ping scans, SYN, ACK/IP protocol scan, ARP and UDP ping scans. ARP ping scan and ARP ping scan sends ARP packets to discover all active devices within an IP4 range, even if those devices are protected by firewalls. Since many IP addresses on a local area network, LAN, are often unused, sending IP packets like an ICMP echo request requires the operating system to first resolve the target IP to a hardware, MAC, address using ARP. An ARP scan directly requests the MAC address associated with an IP. If a host is active, it will send an ARP response. If there's no response after several attempts, the host is considered offline. This method is highly efficient and accurate for discovering systems on a local network. Attackers use tools like Nmap with the PR option to perform an ARP ping scan. UDP ping scan. A UDP ping scan operates similarly to a TCP ping scan but sends UDP packets instead. Nmap, a popular scanning tool, sends UDP packets to a very uncommon port, by default, 40,125, on the target host. If an attacker receives a UDP response, the host is confirmed to be active. If the host is offline, the attacker might receive an ICMP error message, such as host unreachable or TTL exceeded. The POO option in Nmap is used to execute a UDP ping scan. ICMP ping scans. ICMP echo ping scan. An ICMP echo ping scan is a classic technique that involves sending ICMP echo requests to a host. If the host is online, it will return an ICMP echo reply. This method is useful for locating active devices and checking if ICMP traffic can pass through a firewall. Nmap uses the P option for this type of scan. ICMP echo ping sweep. A ping sweep automates the process of sending ICMP echo requests to a range of IP addresses to determine which hosts are live. While a single ping checks one host, a sweep creates an inventory of all active systems on a subnet. It's one of the oldest scanning methods and works by sending a small data packet to each IP. A reply indicates the host is online. The sweep also measures the round-trip time, which is the time it takes for the packet to travel to the target and back. Attackers often use subnet mask calculators to identify the range of hosts in a subnet and then use a ping sweep to map out the live systems. Ping sweep tools. Several tools are designed to perform ping sweeps efficiently. Angry IP Scanner. This is a fast IP address and port scanner that pings each IP in a given range to check if it's alive. It can also resolve host names, find MAC addresses, and scan for open ports. Its multi-threaded approach makes it very fast. Other popular ping sweep tools include the SolarWinds Engineers toolset and NetScan Tools Pro. Ping sweep countermeasures. To defend against ping sweeps, organizations can configure firewalls and intrusion detection systems, IDS, like Snort to detect and block rapid ICMP requests from a single source. Limit ICMP traffic using access control lists, ACLs, and only allow necessary ICMP types through the network perimeter. Other ICMP discovery techniques. ICMP timestamp ping. an attacker sends an ICMP timestamp request to a target. If the target responds, it confirms the host is active, even if standard echo requests are blocked. Nmap uses the PP option for this scan. ICMP address mask ping, similar to the timestamp ping, this technique sends an ICMP address mask query. A response indicates the host is online. This is another way to discover hosts when echo pings are filtered. Nmap's PM option performs this scan. TCP and IP protocol scans TCP SYN ping scan. This technique sends a TCP SYN packet, the first step in a three-way handshake, to a specific port on the target, typically port 80. If the attacker receives a SYN/ACK response, the host is considered live. The connection is then immediately terminated with an ISD packet to avoid a full connection, making it a stealthy discovery method. Nmap uses the PS option for a TCP SYN ping. TCP ACK ping scan. In a TCP ACK ping, an attacker sends a TCP ACK packet to the target. Since no connection was previously established, a live host will respond with an ISD packet. The reception of this ISD packet confirms the host is online. This method is particularly effective at bypassing firewalls that are configured to block incoming SYN packets. The PA option in Nmap performs a TCP ACK ping. IP protocol ping scan. This advanced technique sends IP packets with different protocol numbers in the header, for example, ICMP, IGMP, TCP, UDP. Any response from the target host, regardless of the protocol used, confirms that it is online. Nmap's PO option executes this scan. Port scanning. Once an attacker identifies live hosts, the next step is to find open ports and the services running on them. Port scanning is the process of probing a host, to identify which ports are open, closed, or filtered. Common ports and services. Port protocol service description 21 TCP FTP file transfer protocol 22 TCP SSH secure shell 25 TCP SMTP simple mail transfer protocol 53 TCP/UDP DNS domain name system 80 TCP HTTP hypertext transfer protocol 443 TCP HTTPS HTTP Secure 3389 TCP RDP Remote Desktop Protocol Export to Sheets. Port scanning techniques. TCP Connect/Full Open Scan, ST. This is the most reliable and basic form of TCP scanning. It uses the operating system's connect function to attempt a full three-way handshake with the target port. If the handshake completes, the port is open. If the connection is refused, the port is closed. The main drawback is that this scan is easily logged and detected because it creates a full connection. Stealth scan, TCP SYN scan, SS, also known as a half-open scan. This is a more stealthy technique. It begins a three-way handshake but never completes it. The scanner sends a SYN packet. If the port is open, the target responds with a SYN/acknowledgement. The scanner then sends an ISD packet to tear down the connection before it's fully established, avoiding logging. If the port is closed, the target responds with an ISD packet. This method is less likely to be detected than a full connect scan. Inverse TCP flag scans. These scans send TCP packets with unusual flag combinations, FIN, URG, PSH, to probe a port. According to RFC 793, a closed port should respond with an ISD packet, while an open port should drop the packet and send no response. These scans are highly stealthy but are only effective against non-Windows systems. Christmas scan, SX, sends a packet with FIN, PSH, and URG flags set. FIN scan, SF, sends a packet with only the FIN flag set. Null scan, SN, sends a packet with no flags set. TCP MIMON scan, SM. This scan is similar to the inverse flag scans but uses a fin/ACK probe. A closed port will respond with an ISD packet, while an open port will typically drop the packet. ACK flag probe scans. An attacker sends a TCP ACK packet, and analyzes the response to infer the port's state. This is primarily used to map out firewall rules sets. TTL-based scan analyzes the time to live (TTL) value of the returned ISD packet. A different TTL value may indicate an open port. Window scan (SW) analyzes the TCP window size of the returned ISD packet. On some systems, open ports use a non-zero window size in the ISD packet, while closed ports use a zero. Idle/packet header scan. See, this is a highly advanced, completely blind scanning technique. It uses a zombie or idle host on the network to send spoofed packets to the target. The attacker probes the zombie's IP fragmentation ID number before and after sending the spoofed packet. By observing how the IP ID changes, the attacker can determine whether the target port is open or closed without sending any packets directly from their IP address.